Okay, good day. Today we want to look at under phrases addition of vectors. Addition of vectors. Now, when vectors are acting in the same straight line, their sum is found by ordinary addition or subtraction. When the vectors are acting on the same straight line, if you have two vectors acting on the same straight line, you can find their sum by ordinary addition and subtraction. In adding vectors, their directions are considered. So this line, you have to take note of it. Anytime you want to add vectors, their directions are highly considered. Now the addition of two or more vectors gives a vector known as the resultant vector, the net vector, or the total vector. So anytime you add two vectors together, the sum you get or the final answer you get is known as the resultant vector, the net vector, or the total vector. So now let's look at two very cases. Now, adding parallel vectors. Adding parallel vectors. Parallel vectors simply means they are vectors that will never meet. So let's say this vector 1, this vector 2. You can say vector 1 is parallel to what? To vector 2. So this vector 1 and this vector 2. Vector 1 is parallel to vector 2. What it means is that they will never meet. These two vectors will never meet. Now, under this vector condition, there are two cases we want to look at. So let's look at the case 1. Under this vector condition, let's look at two cases. Now the case 1, consider two parallel vectors v1 and v2. Let's consider two parallel vectors v1 and v2 having the same direction, So now I want to consider two parallel vectors under case 1, v1 and v2 with same direction. That is to say, v1 points towards this direction and v2 also point towards this direction. v1 and v2. So now what happens is that if you have such a case and you have to find the resultant, the net or the total vector, the net or the total vector, it's very simple as what? v1 plus what? v2, which is equal to v. So therefore, the net or the total vector v will then be equal to v1 plus what? v2. When they are what? On the same direction, or when you are pointing the same direction. A second case, case 2. We want to consider two parallel vectors, and these two parallel vectors, they are pointing at opposite directions. So we want to consider v1 and v2 as parallel vectors with opposite directions. So what it means is that if v1 is pointing this direction, then v2 is pointing the opposite direction. And now, if you have such a case, then the resultant vector v is equal to v1 minus v2, where v1 is greater than v2. Or the resultant vector v is equal to v2 minus v1, where v2 is greater than v1. So these are the two cases you have to consider when we want to deal with addition of parallel vectors. Let's take two examples. Alright, so now these are the two questions. And the first question says that an athlete runs with a velocity of 50 meters per second in the same direction as the wind blowing at a velocity of 8 meters per second. It says you find the resultant velocity. And you know that velocity is a vector quantity. Find the resultant velocity of the athlete. So what happens is that as the athlete is running, you know that there's the speed of the wind. So the normal speed of the athlete is 50 meters per second. And the speed of the wind is 8 meters, which will help the athletes run at a certain resultant velocity. And that is what we want to look at. So now, solution. So we have the athlete running towards this direction. It says in the same direction with a speed of 60 meters per second. And we have the wind also blowing towards the same direction with what? 8 meters per second. So therefore, the resultant velocity v, so let's say this is equal to v1, this is v2. The resultant velocity v, because they are in the same direction, is like the case 1, which will be v1 plus what? V2, and that is equal to 15 plus 8 meter per second, and you get 23 meter per second in the same direction. So this will be the resultant velocity of the athlete. Now let's come to this question. It says two forces, 10 Newton and 4 Newton, pull a body in opposite directions. Find the resultant force. Find the resultant force. Okay. So solution, let's say this is the body. And we have two forces. That is, let's say force 1, which is what? 10 Newton, pulling the body this way. And let's say you have force 2, which is what? 4 Newton, pulling the body in the opposite direction. Or we can draw the diagram as this way. We have 10 Newtons here, pulling the body here, and we have 4 Newtons here, which is also pulling the body in this direction. What happens is that they are parallel vectors. So now this F1, this F2. So therefore the resultant force we are looking at, let's say that is F, becomes, because they are pulling in opposite directions, becomes F1 minus F2. Because since F1, the value for F1, the force F1 is greater than what? The F2. So therefore, the resultant vector becomes 10 minus 4 newtons, which will give what? 6 newtons. Okay, thank you for joining this video, and kindly subscribe to the page.